and welcome to another math tutorial. This video is simply an extra set of problems to practice on absolute value inequalities. What I would suggest is at the start of each problem, you pause the video, attempt to work the problem out yourself, and then once you have a solution, you can press play or fast forward to the end of that problem and check your solution. If you need some help in the explanation, then obviously I would suggest watching the solution of each problem. First problem, I see absolute value 5x minus 7 is greater than 13. There's no other numbers on the left side with the absolute value, so I can go ahead and just begin solving right away. It's a greater than, so that tells me it's going to rewrite as an or statement. So I want 5x minus 7 is greater than 13, or 5x minus 7 is less than negative 13. All right, so we're going to add 7 to both sides. Let's just do both at the same time. It's the same steps. So we've got 5x is greater than 20. And here we have 5x is less than negative 6. We're going to divide both sides by 5. We get x is greater than 4, or x is less than negative 6/5. Now, number line, you can draw one if you need the assistance of the number line. So let's just go ahead and do that real quick. The negative number is smaller, so I'm going to put negative 6/5 on the left side. I'm going to put positive 4 on the right side. And we want numbers that are greater than 4. We want numbers that are less than negative 6/5. I encourage you to draw the number line if it helps you write the interval notation. If you can go from these inequalities directly to the interval, then I would say you could probably skip this unless you're specifically asked for it. But if it's helpful, then I would go ahead and draw it out because it doesn't take long to do that. Okay, our solutions then are from the number line. Reading off that, we want negative infinity to negative 6/5, or we want 4 to positive infinity. All right, our next problem. First thing I notice is this minus 3 needs to move over to the opposite side, so I'm going to add that 3. So I have absolute value of x plus 4 is less than or equal to 5. Now, because this is a less than, this tells me that this is an and statement, compound inequality. When it's an and statement, I'm going to write one long inequality. So I want x plus 4 is less than or equal to 5, and it's greater than or equal to negative 5. Okay, all I need to do is subtract 4 from both sides. That's going to take it out of the middle. So we're going to have negative 9 is less than or equal to x less than or equal to 1. Now, if it's an and statement, we were looking for an intersection on our number line. So we can interpret this just as it reads, and that we want a solution that is between negative 9 and positive 1. Again, if you want the number line, there's no reason not to draw it, because the number line, real quick, negative 9, 1, we want closed circles. We want everything between those two numbers. So if it helps to see that, do it. But if you can go right to negative 9, 1 without the number line, I think that's fine too. All right, our next problem begins with this plus 8 that I do need to move to the opposite side of this inequality. So I'm going to rewrite this as absolute value 3x is greater than negative 3. Because it's a greater than, that's an or statement. So we want 3x greater than negative 3, or we want 3x less than positive 3. Okay, so we're going to solve both of these. It's just a simple divide by 3 over on both of them. So we get x is greater than negative 1 or x is less than 1. All right, let's go ahead and take a look at this one on the number line just so we're not confused how to interpret this. So we want negative 1, we want positive 1, and we want numbers that are greater than negative 1. So open circle, greater than goes this direction. Or we want numbers that are less than positive 1, like so. Because solutions can be in either this region or in this region, and we've shaded the entire number line, the solution then is everything from negative infinity to positive infinity. Okay, our final example problem. I am going to begin by getting the absolute value by itself, so we are going to divide both sides by negative 5. So that gives us the absolute value of x minus 3. Remember, when you divide by a negative with inequalities, you change direction. So now we're less than or equal to negative 3. So what started as a greater than and looked like an or statement is actually a less than. So this is going to be an and statement. So when I write this, I'm going to write it as one large inequality. I'm going to write x minus 3 is less than or equal to negative 3 and greater than or equal to positive 3. Okay, we're going to add 3 to both ends to get it out of the middle. So we end up with 6 is less than or equal to x, which is less than or equal to 0. Now, this is kind of interesting and definitely worth your consideration to definitely, I think, look at a number line. This is interesting because reading these compound inequalities like this, the numbers should go least to greatest, and this definitely is greatest to smallest. So it's a little unusual right now. So let's go ahead and take a look at this number line. We need to have 0 and 6 on the number line. And I'm just going to take them separately. So I've got, if I read this side, it's just x less than or equal to 0. Equal to, shading that direction. If I read this side, it reads x is greater than or equal to 6. So we've got that. Now, we've seen number lines like that before. We know how to write the solution to number lines that look like that. So that's not really a problem, except this inequality was an and statement. And what I'm looking for is an intersection. In order for a number to be a solution to this problem, it has to be in both shaded regions, right? It has to be some sort of overlap. If I pick a number out here, it's in this region, but it's not in this region. And likewise, if I pick a number out here, it's in this solution, it solves this one, but it doesn't solve this one. So there is not a number on this number line that solves both of these, right? In other words, there's not a number that is bigger than 6 and smaller than 0. Because there isn't a number that fits that description. The answer to this is that there is no solution. Okay, that's it for my extra set of example problems for absolute value inequalities. If you found these helpful, please go ahead and give the video a like. If you have any comments or questions, please leave them below, and I'll see you in the next one.